It's lit, fam. Hello. Wow, look at this! This area has come so far in the past few years, and with the lights in particular, I made it so much harder on myself than it needed to be. I mean, could I have just gone out and bought a regular smart LED strip with a controller and called it good? Sure. So anyway, let's design everything from scratch and reinvent as many wheels as possible. Okay, first let's rewind a little bit and go over some things. If you haven't seen the first part of this build, you can watch that to see how this project started and watch the actual table come together from scratch. But if you've got a keen eye, you might notice that some of the CAD shots are different than what we ended up with here. I initially planned for this pegboard to fit perfectly flush with these drawer systems, which it was for a while, but that was before I had the idea to put lights on this thing, in which case it actually needs a bit of room so the drawers don't just cover up the whole bottom strip. So the first thing I did was grab a spare RGB LED strip I had lying around so I can just see how it would look on the wall. I figure if it looks like trash now, I don't want to pour hours and hours of my life into it. Fortunately, it didn't look like trash, so I went and got some proper 12-volt strips, and they aren't addressable, but I figure I can section them off and get enough control that way. For those of you who have no idea what I just said, 60-second crash course on LED strips, here we go! By the way, this motion graphic you're about to watch took like 14 hours to make, but it was fun, so. We all know what an LED is, they're literally everywhere these days, it's just a type of light bulb. RGB LEDs are actually 3 LEDs mushed very close together, red, green, and blue. By combining those colors at different brightnesses, you can make it look like pretty much any color you want. For those of you who know some color theory, you know there are technically some limitations, but that's why I said pretty much. LEDs can also come in long strips, one after the other, and I can almost guarantee you've seen these in action somewhere. LED strips come in 2 main types, global and addressable. Global strips are just a bunch of LEDs wired together, so you hook them up the exact same way you would for just one bulb, and it powers all of them. Addressable strips have a little microchip for each bulb, or sometimes every 2 or 3 bulbs, and it makes it so you can actually send data to it and control each one separately from the rest. Addressable strips are really cool, and I've used them a lot in the past, but they are more expensive and they usually use 5-volt power, whereas a lot of global strips use 12 volts, making them a bit brighter. What I plan to do is get 4 global strips, one for each side of the pegboard, and control those separately. It won't be as fine control as fully addressable, but I think it'll be good for this purpose. The test strip I was using was a 5-volt addressable strip that I just had lying around because I'm familiar with those already, but the 12-volt ones will require some extra hardware to get running. I've got them powered off my lab bench supply. The wires for this strip's red, green, and blue channels are plugged into these MOSFETs, which are basically fully electronic switches, and those are plugged into this PWM driver, and that sounds complicated, but all it does is turn those switches on and off really fast so it looks like the LEDs are different brightnesses. This is an Arduino Nano, which is the brains of the whole thing, but most importantly, these 4 sliders here respectively control red, green, blue, and then the 4th one is like a master brightness. So that looks really good on the wall, even just jankily draped over the pegboard like this, so I think we're ready to start soldering some wires onto this thing. So behold, my amazing, professional, talented soldering skills of a master electrical engine. What is that? That's so bad. What's going on? Yeah, okay, so it turns out tinning is kind of important. That's when you first melt a little coating of solder onto both of the things that you're working with, and then when you join them, they just kind of flow and fuse together really easily. Way easier than whatever the heck I was doing there. So after figuring that out, look how good this one turned out! Gracious, that's so much better! One of these days, I will remember to put the heat shrink on before I solder the wire. Today is not one of those days. With those wires attached, let's plug it back into the test circuit and make sure it all still works. Okay. Yeah, that works. That looks good, so now it's time to get serious. No, wait, it gets better, hold on. Okay, but really, this is gonna be some of the most complicated proto board I've ever made. In fact, looking back, I really should have just designed something and ordered custom PCB from an online service, but for some reason, I like making things hard on myself, so here we go! This is actually going to be in 2 sections. Right now I'm just finishing up the board for all of the MOSFETs, but now let's get started on the other board, which will be controlling everything. Okay, so after cleaning things up a little bit and getting stuff ready and about having a heart attack after the power went out and I thought it was my fault, but turns out we're just in the middle of some heavy rains and stuff, I think this is finally ready to get its very first test in the protoboard form. So, I've got power right here. This is kinda scary because there's only so much I can test with this, and I really hope nothing blows up. Safety goggles! Okay, so when I first plug this in, nothing should happen because this is actually on a separate outlet switch to the power supply. Okay, good. So now we turn this on and hope nothing blows up. I'm not even plugging in the LEDs just yet. I just want to see if the circuit doesn't blow up. Okay, we have power. Second question is, can I plug it into a computer without this, or more importantly, the computer blowing up? Okay, everything seems good. Does the computer see it? Okay, yes it does. Alright, let's test this with one strip first. Let's try it with this guy first. Okay, so now turn this back on, and that should all be fine. Oh, why is it green? That shouldn't happen. Okay, what if I just plug it into the next row and ignore my problems? Does that work? Why, I'll be. It absolutely does. We do have serial. If I send a command, and boom. Okay, so that works. Like if I do red, green, oh, that's... Why are blue and green both active? Great, more problems. Okay, so blue and green are shorted together. Love that. Right, okay. Continuing the saga of ignoring my problems, let's try the next one and see if any of these work. Alright, so this should be a mock-up of the left strip that I'm testing, I think. Okay, we have red and green. Good. And blue is not working at all. Great. Okay, turn this off. Let's try the last segment. Let's try red. Nope, that's shorted to green. Brilliant. So that means if I do green, nothing changes. Great. Does blue at least work? Yes, it does. Okay. Alright, well, I've got some work to do. Okay, so after realizing that my head was chopped off and sleeping on it and staying up later than I probably should have before that, a thought occurred to me, and that is, I was like, I wonder if these heat sinks conduct electricity. Oh, they do, and these two are touching, but that shouldn't matter, right? Well, turns out the heatsink is connected to the middle pin on these MOSFETs. So since these are touching, that means that these two middle pins are shorted together. That shouldn't happen. And you'll notice these two are fine. It's only these two and those two are fine. These two, those two are fine. Those two are fine, fine. These two. And that probably means nothing to you, but I know that that's the exact same pattern I was seeing problems with here. So when the colors were shorted together, that's like these two That's the blue and green channel of the one that was shorted there. And additionally, that means that since these are like flat against the protoboard, if any of the solder on this side spilled through to the other one, then those heat sinks are shorted to whatever the frick is on here. So that could also explain why one of them wasn't turning on at all and one of them was always on. In fact, honestly, I'm kind of surprised nothing like burst into flames when I tried this, because like there's shorts all over the place. Oh my goodness. This is a disaster. So, point is, how do we fix this? We need something to insulate those heat sinks, and so I was thinking I'm going to start by just kind of bending them up a little bit and staggering them so that they aren't touching, and we'll see if that works. Okay, they are now bent up. Let's make sure none of them are shorted. Okay, good, no shorts. So now we should be clear to give this another test. So if everything went well, when I turn this on, we should see nothing. Last time the green and blue were on for some reason, so let's hope that doesn't happen. Good. We should have red, good, green, and blue. Yes! Oh, that makes me so happy. Yeah, baby! Okay, proof of concept. Sick! Okay, let's try the next one. Okay, we are now plugged into the next set. Okay, we've got red, green, blue. Sick. Next, red, green, blue. Awesome. Last one. If this works, that means we've fixed everything. Let's see. Red, green, blue. We've got 4 working sections. Woo! All right. So that means this is finally ready for some actual further development. Finally. I'm gonna make a program that sends data over here faster than I can manually type commands, because that's stupid. I'm gonna design a housing for this, plug in all the strips. Oh man, we can actually move forward with this. Okay, I was so worried something was going to be like irreparably broken with this. All right, this is awesome. Let's go. You know, on second thought, something I should probably try is all of the strips at once. So here's that setup. Schleifte Glagels. I don't know what that was, but anyway, here we go. Alright, cool, nothing's blowing up. Let's send some serial commands. So these are in no particular order. I don't know, I just kind of did randomly. So let's just start with the top, whichever one that is. Oh yeah. So now bottom. Excellent. And left. Sweet. And right. Awesome. And just for funsies, red on that strip, green on that strip, blue on that strip, and white on that strip. All right. This is freaking sick. Freaking look at that. Oh, I feel like I should also mention this is a quarter brightness, so this can go a lot brighter than that. So now that one's at a half brightness. You know what? I'm gonna go all out, full brightness. So this is really freaking bright. This is full brightness on all strips. Everything looks okay right now. Still no excessive heat anywhere, so that's great. I don't know if this translates on camera, but this is like brighter than my studio lights right now. Oh, this is so freaking cool! I love this so much. That's freaking sick. Everything smells good. Tastes good. Do I have wild techniques? Absolutely. But is it legitimate? Absolutely. Because I'm smelling for melted things, and I'm not actually tasting it. I'm just, my lips are a lot more temperature sensitive than my fingers, so if I want to really check the temperature of something, I always kiss it. One of the weirdisms of the way I work. Anyway, now this is ready to move forward. This is so cool! Okay, update, it's yet another day, and I've written a little bit of code for this thing. So this is a program called Processing, which can very easily interface with the serial port on the Arduino, so I can pass data back and forth between these really easily, and that's great. So this just has like the master code of like, tell me what to do and I'll do it. This has the here's what to do code. So I actually just finished putting the finishing touches on this, so we're going to try this out for the first time. Alright, so we've got our initialization there. Arduino just told us it's ready to go. So now, if we bring in some colors, hey! And we can adjust the brightness. There we go. There's something. And you can see we've got a little mirror here of like what it should look like. So as I change the color and stuff here, that'll update to match nicely. And that works for all of them. And yeah, you can see this is like mirroring what that should be. We've got like a super snappy response time here. That's awesome. So next up might be we could drive like some animations from this or something else, some kind of remote, I don't know. The USB is just gonna be temporary until we get Wi-Fi on this thing. But for now, this is great. I can work with this. So let's design a housing and get this thing installed, for crying out loud. Alright, we got some parts. So the idea is all this is gonna go in here, and then the lid goes on like that, and then we just have this nice little pancake package here. So let's see if this actually fits, because I am not entirely sure it will. Alright, now before we put the lid on, I actually want to give this a test with everything still open so that I can see if it works now that I put it in there. Make sure none of the wires got jiggled loose or anything. Shoot! Okay, let's see if we can fix that.
1 hour later.
Okay, that took way longer than I thought it would. Actually, that's not true. It took about as long as I thought it would. That was rough. Anyway, let's give this another shot. There we are. Let's see what happens when we plug a computer into this. Alright. That is working. Okay, so now let's put the lid on it and see if it still works. Okay, let's put in some screws. This is so incredibly janky. Hope I'm not screwing into anything, because I didn't check that measurement. Okay, so as you can see, this is kind of janky right here. This comes up and that like it's just not secure, but ultimately this will have a pegboard squishing it from both sides, so that should be fine. I'm gonna go with it's fine, and let's just see if this still works. Now, I deliberately made this light proof so that the power lights and stuff don't shine through the pegboard, because I don't want to see that in the backdrop. That's what the actual LED strips are for, but that also means that I won't be able to troubleshoot right now, so I'll just have to turn it on and hope for the best. And the only way that we'll know if something is going wrong is if we see smoke. Alright, okay. Yeah, alright, it works. Cool beans. We have a box that does stuff. That's freaking awesome. Uh-oh. The one thing that I didn't check. Aw, man. Something shorted. Guessing it's just a couple of the MOSFET heat sinks that are getting a little too friendly again. Oh, would you look at that? I was right. These two look like they're close as well. Yup. Let's see if we can just slap the lid on that and call it good. Wow, I can't wait to make a better version of this. This is so janky. Okay, take two. Okay, red, green, blue, red, green, blue, red, green, blue, and red, green, blue. Okay, we're good. Hey! Can you see that? Not really. Come here. What is that? What incarnation.
It's showing through the layer lines.
Whatever, it'll be up against the wall, it's fine. And I think we're finally ready to move on to the non-electrical hardware part of this. Of course, I said that last time and I ended up having to fix this a bunch of times, but let's hope it's for real this time. So the idea is I want the strips mounted to a metal rail going around the perimeter of the pegboard like this. I found some stuff at the hardware store that'll be absolutely perfect for that, so let's just cut some divots in it for it to bend nicely. And you get to see some cool metal sparks, which is not something that happens often on this channel since I work in my bedroom, so enjoy! With those ready to go, I'm gonna mark where the pegboard was and then take it down to expose that Nerf dart, apparently. What is that? How does that even happen? What? Now that this is on the table with the backside exposed, let's see if we can put this all together. With the strips and rails roughly in place and full-scale wires plugged in, let's do a quick check to make sure this thing is still operational. Okay, we have an update. Oh wait, yeah, it's just over here. Oh, it's that one. Yeah, okay. Now we have that one, and this one. Sick! There we go. All right, we're getting there. Man, what's the next step? I really expected something to break by now. Right, actually securing things. Okay. I designed and 3D printed some brackets. That was more aggressive than I intended. Some brackets and spacers, which are looking lovely. Yeah, nice aesthetic shot. I totally didn't just drop these. So let's get those attached. Oh, that's nice. That's real nice. And I'm just gonna do one of these. There's that. All these are nice and secure. Love that. Time to slap this thing on there. In fact, hang on. Let me try just, there we go. And let's just clean up these wires. There we go. Yes, it's just scotch tape everywhere. Don't judge me, I'm on a time crunch here. But let's test it out again, make sure it still works. Good. Uh-oh. Oh wait, yes. And good. Now what? Mounting it? Sounds good. Now's also a good time to take down the skateboard shelf, since the pegboard will be higher up on the wall than it was. And speaking of which, let's grab some temporary supports that happen to be the exact height we need, and get this thing up on the wall. Okay, as you can see, this is now fully installed, or like put up on the wall properly. It's plugged in on the switch there. So yeah, extreme emotion inbound. Whether it's positive or negative will depend on if this works. Okay, we have cereal. There's blue, green. Uh-oh, there it is. Yes! Oh, that looks so good! That looks so freaking good! Hold on. Let me crank up the brightness on this really quickity chickity. Like, boop. Oh my gosh, that's amazing! Okay, we do have A little bit of shadow on the corners, which I was worried about. Might be able to fix that later, but it's honestly not major. Like, this looks so freaking good. Oh my goodness, this is absolutely amazing. I love it. Okay, let me go ahead and do a full test here just to make sure this is not premature. Okay, so we've got on the top, red, green, blue, left, red, green, blue. So this should be right. Yes, red, green, blue, and then the bottom, red, green, blue. All right, we have full functionality. This is sick. And we can make like different colors. We can get some white, like a fuchsia kinda. Oh, this is so stupidly cool. I mean, come on. Tell me this is not. And look at the visuals. Oh, it's finally done. Sort of. At least enough. It's done enough for now. All right, we got some sick LEDs. So the next step is going to be mounting that, and also getting like general organization here with all of the tools and whatnot. But yeah, this was great progress. I also decided to put some black electrical tape around the edge, mainly because there was some light bleed in that outermost set of pegboard holes, but honestly, I think it looks even better overall like this. Here's roughly how I want the tools organized, and I'm sure this will change and evolve over time, but for now it's a start. So now that the tools are started, let's go ahead and put the drawers back on the table and then get that power hub mounted to the wall. Probably should have put in some anchors on that, but I'm gonna wait till that comes back to bite me in the butt to worry about it. Future me, it's almost exactly 2 years later, and it hasn't caused any problems yet. However, one of the USB ports actually did get broken, but it didn't come out of the wall, so... With that done, let's go ahead and put the skateboard shelf back up, nice and centered over the pegboard, and unlike before, I'm just gonna put some small brackets holding it up on top so that the bottom stays nice and clean. It won't be nearly as strong that way, but for the most part I won't be touching it, and it doesn't need to carry much. And with that, we are finally caught up to the present. Most of that stuff was recorded almost 2 years ago, but it is now November of 2024, and as you can see, the pegboard has indeed evolved a little bit. I'm starting to fill in these drawers here. I got some nice little trinkets on the skateboard shelf right there, and actually if you look up a little bit, you can see I got a nice light installed on the ceiling there, and that really helps even stuff out. I also very recently got a kit that's supposed to help with squeaky floors, which I was in dire need of, because it gradually got worse and worse over the years until every tiny shift of my weight would result in the whole floor literally screaming at me. So what this does is you can find the joists of your floor and then put a screw in wherever it squeaks to secure the floorboards to the joists. And with this you can just go right through the carpet without having to rip it up, because this tool stops the special type of screw at just the right height that you can use the built-in grabber here to snap off the head right where it's partially cut, leaving the break point barely recessed below the floorboard where it won't stick up at all. Disclaimer here, do be careful when you're doing this. The last thing you want to do is accidentally drill into some electrical wiring, or worse, some plumbing underneath your floor, because then you'll have a far bigger and more dangerous problem on your hands than some squeaky floors. I was very confident in the placement of both the plumbing and the electrical under my floor, leaving me free to feel around with some test holes and find where the joist is in one specific area, and then test around to figure out which direction the joist is going, and once I know that, I can mark out the rest of the joist and then measure across in 16-inch intervals to map out the rest of my floor without any more test holes. So just please do not drill into your floor randomly unless you know what you're doing. So you just do that for as many squeaky spots as you have, which for me was a lot, but once it's finally done, the results are almost magical. I cannot believe I didn't do this sooner. Literally, I'm so happy I could almost cry, because as a hypersensitive person, this was bothering me so much. But now that we're caught up to the present, there's one thing left that's really important to me and that I've also been meaning to do for a long time. What if we put the keyboard on the wall? Let's whip up some mounts for this boy and print that out. This was slightly too big to fit on my printer, so just like with the longboard electronics housing, we're gonna split this up and epoxy it together. Except this time I actually got some bigger clamps, so I don't need to put a dictionary on top of it and just pray it doesn't tip over. But yeah, you might have been able to see in the background, that's what all this stuff is. That's the brackets that I printed out. The bottom part has these nice chonky brackets I found, and there's a stud in the wall right where the center one needs to go, so that should be perfect. Nice. And then the top one has this hinge joint, so I can still easily take out the keyboard and use it whenever I want. Let's get that installed, and we are looking good. Oh yeah. I also made a mount for the two X keys, which when put together end to end are just slightly smaller than the Alesis over there, so these will look really nice on the other side of the pegboard. And these are stupidly lightweight, so fully plastic mount, no studs in the wall, that should be perfectly fine. How did I screw it up that badly? The fudge muffins. Let's go! Yeah, that's actually really good. Okay, cool. Instead of a hinge, I made this middle part have a magnetic cap to keep them in place, using one of the many cool things you can do with 3D printing, where you actually embed magnets, or anything else really, mid-print. It makes it look really seamless and honestly also kind of magical. So now that those mounts are installed, let's put the X keys in place. Make sure everything looks good. Nice! And finally, take a step back and look upon the glory of this wall. This is an awesome place to film now, and I feel like it really represents the core parts of who I am and what this channel's about. We've got all the tools in the middle, we've got the work table for projects, super accessible, we've got keyboards flanking either side like music giving us a big hug, we got the skateboard shelf up top, and everything beautifully lit by these gorgeous lights. Now, this is surely not this area's final form. I'll probably change stuff on the pegboard as needed. There'll be different projects on the table as I'm working on stuff. I might swap out the skate shelf trinkets. These drawers might move because they're kind of ugly right now. Not to mention, I've already filmed some stuff for future videos where this whole area was in different stages or didn't exist at all, so from now on, I'm just gonna embrace the inconsistency. However, that being said, there is one other thing I've been kind of hiding this whole time. If you watched my 2023 update video, I mentioned that I got some parts for building my own PC. And if you're extra keen and noticed in my last few videos and this one, I've done some little commentary bits from my desk where I was in front of a big ol' monitor instead of my tiny laptop screen from before. So yeah, spoiler alert. I built the PC! So yeah, the next few videos will be a series on my adventures doing that, and if you don't want to miss it, be sure to subscribe to the channel and hit that little bell so that you get notified the second that I upload. And if you liked this video, there's a handy button for that too. You can let me know with the like button. And if you stayed this far, I've got a special treat for you. I'm feeling risky, so I think after a few years of using this table, I'm ready to actually sit on it for the first time. I've legitimately never done this before. Here we go. Full weight. Let's go! Okay. Whew. Never doing that again, but yeah, it holds my weight. But yeah, we've got the engineering, we've got the music, we've got the vibes, so until next time, make something, sing something, hug someone, and I will catch you in the next video. If you're extra cream cap to keep them printing? What? Oh, I skipped a line. Wow, I can't make How do I make this less obnoxious? Oh, just like that, I guess. Time to get serious.